So what is meant by regression means just it is going to predict the output variable which is continuous, right? Now in the last class we have taken a simple data set that is with respect to x and y values. What are the x values I have selected? 1, 2, 3, 4, 5. And what is the y values? Okay. For this 6, 4, 5, 5, 10, first this is the data. So for this data, you have made the model. Whatever the model is there, that model. What is the model? Y is equal to 3.3 plus 0.9 into x. This is called as model. Now using the model, you have done the prediction. So what is the predicted y hat? What are the predicted y hat values? 4.2, 5.1, 6.9, 7.8. So you are having the predicted values like this. So data is ready, model is ready, prediction values are ready. Once the prediction is completed, after that we have done the evaluation. Now for evaluation, whatever the thing we have done is, first we have selected the original y versus predicted y. Original y is 6, 4, 5, 5, 10 and predicted y is 4.2, 5.1, 6, 6.9 and 7.8. So using these two, you have calculated the first mean square error. Mean square error means y minus y hat is called as error. After that, square to that, and you have applied the mean to that is called as mean square error. Next, RMSE. RMSE is again the same error. Whatever the error is there, square of the error, mean of the error, and square root of the error. This is the one. So in the last class, we have done with respect to MSE and RMSE. Now the question is, there is one more with respect to called as R square. Within the evaluation, one more which is called as R square, which is called as coefficient of determination. Coefficient of determination. Right? So what is meant by coefficient of determination? Means how much it is determining, how much percentage it is determining the y value based on x values. How much percentage you are determining the y value based on the x value. Means for example, in the future, for example, x is equal to 1, 2, 3, 4, 5. For 6, what is the expected value? 6 into 0.9, that is 5.4 plus 3.3, which is 8.7 is the expected answer using your model. That is model is equal to y hat is equal to 3.3 plus 0.9 into x. So just you are substituting this 6 value and you are going to get 8.7 value. But okay, 8.7 fine. But with what percentage you are saying this one? 90%, 70%, 60%, you are determining it is 8.7. You are estimating or determining or predicting, everything is same. Okay. You are predicting with 8.7 is the answer. For x is equal to 6, 8.7 is the answer. You are determining 8.7 is the answer. But with what is the percentage of determination? That gives the coefficient of determination. Now this coefficient of determination was calculated based on the formula called as R square is equal to 1 minus sigma of y minus y hat whole square divided by sigma of y minus y bar whole square. Don't write the formula. Don't write the formula. Here the formula is not important. Here how it is has derived and what is the importance of this one is important. The thing is that, for example, assume that there is a restaurant and there is a waiter. And the waiter has collected the data like this: total bill and the tip amount. Now, for example, he has assumed that there is no total bill, only tip amount is there. Tip amount, first meal, whatever the first meal is there, he has got the meal amount of, assume that it is $6, he has got a tip. For the second meal, he has got $2. For the third one, he has got with respect to $1. For the fourth one, he has got with respect to $3. For the fifth one, he has got with respect to again $2 or with respect to $2.5. Something he has got like this. Now, whatever the tip amounts he has got, now what is the expected tip amount for the sixth one, miss? What is the expected tip amount for the sixth one, miss? What you are going to say? which is nothing but average of this one. Blindly, if you are having only one column and it is not dependent on anything, miss, just we are going to apply the mean only. By default, we are going to apply the mean. So here, for example, this value, assume it is 4, and whatever the previous five means whatever this one is there, 6, 2, 8, 9, 12, 16. 16 divided by 5, which is nothing but 3.2. He will expect a tip of 3.2 is the expected value based on the last 5. Right? So, for example, this particular waiter is working in a particular restaurant. First day, he has got some amount. Second day, he has got some amount as a tips. Total amount of tips. Third day, he has got some amount. What is his expectation on going to the fourth day? When he enters into the restaurant on the fourth day, what he will expect on that particular day tip is the average of these 3 only, right? And on an average, I will get this one. He will expect something like that, and like that he will assume. So here, this average value is for whenever you are working on a single variable, the average is the best one. For example, for the 7th one, what is the expected tip amount, miss? Again, average only. For 8th one, average only. For 9th one, also average only. Everything average only. For anything, it is average of the previous values. Just is the average of the previous values, whatever the data you are having. For example, I assume this is the only data which you are having. The 6th one, 7th one, everything you are expecting this much only tip amount, same tip amount. 3.2, 3.2, 3.2. Every time you are expecting the same tip amount. Right? Now, whenever you are having only one variable, the best one is called as average. Earlier, they used to work on the average only. So for them, which is the best fit line means average line is the best fit line. Simply average line is the best fit line. And for whatever the original data we are having, original data, this is the original data. First bill, second bill, third bill, fourth bill. On the x-axis, you are having the number only. There is nothing. So this is error, this is the error, this is the error, this is the error. So their assumption is with respect to average line is the best fit line. Okay, whatever the for every value, for example, so the same tip amount, whatever the 6, 2, 1, 3, 4 is there. Now for this one, whatever the original values are there, the predicted value, what is there? This is the actual value. What is the predicted value? Means 3.2 is the predicted value, 3.2, 3.2, 3.2, 3.2, 3.2. For everything, this is the estimated value. Future data also 3.2. Everything is 3.2 only. Just average value is they assume the best fit line is the average line is the best fit line. Now, later, they came to a conclusion, the one statistician who has invented this regression. Now he has told that a tip amount will not be decided like that. Tip amount will be decided based on the total bill amount. So he has taken the bill amounts also, and he has identified the relation between these two. And now for the future data, what is the expected tip amount? Miss, first you tell me the bill amount, then I will tell you the tip amount. He has told that there is a relation called as with respect to y and x will be there. That is y is equal to mx plus c. The average line is not the best fit line. There is a regression line, which is the best fit line, which can predict more accurately. To predict more accurately, I require with respect to the total bill. Without the total bill, then I can estimate only with respect to blindly the average value only. For predicting the average value, no need to do all these machine learning algorithms. Just by seeing the data also, just you can predict. No need to do anything. For example, if you go to your home and you give for your father, December 1st, this is the temperature in Amirpet, December 2nd, December 3rd, December 4th, and December 5th. You give the 5 temperatures. You ask your father, what is the expected value on the 6th? He will simply say, average of 5 days. Though he don't know statistics also, just a common sense only, that one. Okay. Miss Hoon, with respect to any person who are educated persons, I'm saying. Okay. Now here, just they'll say that it is an average only, simply average. Here, there is no machine learning, there is no data science, there is no data analytics also. Nothing is there, just average. So by default, which is the best fit line? Means average is the best fit line. Means the sum of the squares of errors by average line, removing the average line, whatever the sum of the squares of errors is, that is the minimum value they used to believe before. Now we came with a solution that this one, that is sum of the squares of errors. Now the predicted values are different. This equation is different equation. This is not the average equation. So here we are having with respect to y of, what are the example I have written earlier in the numbers? Anyone has written? 6, 4. Not that one. This tip amounts. Okay, fine. What are the tip amount we are having? Sorry, assume that 6, 4, 5, 5, 10 only. Okay, this is the tip amounts only. Now you are going to calculate for predicted value. Every value you are going to take with respect to this one. Now 6, 4, 5, 5, 10 is there. What is the average of this one? 15, 20, 24, 30, 30 divided by 5, which is 6. So for this 6, 6, 6, 6, 6, everything predicted values. This is the predicted value based on the average line. Now you tell me what is the sum of the squares of errors of this? That is y minus y bar. That is 0, minus 2, minus 1, and plus 4. Now y minus y bar whole square. Y bar, I am writing clearly, bar means average value. 0 square, 0, 4, 1, 1, 16. Now what is the sum? Sum of y minus y bar, which is 22. This here the prediction was done based on the assuming the mean value. Now the same thing, the same original y, 6, 4, 5, 5, 10. But this time I am predicting with 4.2. That is next one is 5.1, 6, 6.9 and 7.8. Now this time I am calculating y minus y bar. Now I am going to get 1.8. This one is with respect to minus 1.1. Next one is 1. That is minus 1. 5 minus 6 is 1. Minus 1. Minus 1.9. Minus 2.2. And 2.2 only, right? Plus 2.2. Plus or minus, whatever it is. Y minus y had whole square only. Now we have to do. Whether it is plus or minus, anything is okay, right? So now what is the values? Yesterday, I think we have calculated, right? 3.24, 1.21, 1, 3.61, 4.84. Total is y minus y bar whole square. What is the value? 13.8, right? 9, 13.9. So now here we have got 13.9. Here it is 22. Now out of these two, which is best? For the same y values. Y values was not changed. But here the y hat values, here your predicted values are this one and this is the one. Now, so here when compared to your mean, your regression is doing better. So how much better it is doing? How much percentage of betterness it is doing? Miss percentage. That is sigma of y minus y bar whole square divided by sigma of y minus y bar whole square. That is 13.9 divided by 22. You are going to have some value now. That is with respect to called as how much you have improved. That is now you are going to calculate this value. What is this value? Can anyone calculate? 13.9 divided by 22. Open your calculator and calculate, please. 0.631. So now this gives whatever the value it is going to give. This value is with respect to the percentage it is betterizing. 63%. So it is giving the out of that is 22 into 0.631 is this value 13.9. Just 63% only error. This is assume this is the total error. Now error, how much percentage of error you have got is 63% only error you have got. Means how much better it is than this one means 1 minus 0.631, which is 0.37. This is called as R square. Now R square is nothing but how much your model is better than the mean model. R square says that how much it is better than the mean model. Now you write the formula. that is x minus y bar y hat whole square divided by y minus y bar whole square, which is nothing but 1 minus sum of the squares of errors of the regression divided by sum of the squares of errors of mean model, that is average. So sum of the squares of average, when compared to average, how much your model is better gives you the R square when compared to average value, right? The null hypothesis says that average line is the best fit line, and null hypothesis says that before the invention, they used to say average line is best fit. Average line, whatever the average line is there, null hypothesis says that average line is the best fit line. Average line is best fit line. What is meant by average line is best fit line? Whatever this average line, that is sum of the squares of average, is less than or equal to whatever you are saying your equation, that is regression equation, then that mine is only better. Simply go with average only, it is better. This is the null hypothesis. Now the statistician has told no, average line is not the best fit line. Regression line is the best fit line. Regression line is best fit. What is the meaning of that? SSC of regression is less than your SSC of average. Or just if you want, you can write like this. SSC of average is greater than the SSC of reg. Just opposite to this. Now they have applied. Now SSC of average 22 you have got. 22 is greater than 13.8. Okay, 13.9. So 22 is greater than 13.9. Now you finally have told that regression line is the best fit line. Right? So you are going to apply the hypothesis test and you are going to say that regression is better than the average when compared to. Don't go with the average, go with the regression. Is that clear? Now, what is the maximum you can get the R square? If this value, the SSC can't be negative, right? Sum of the squares of errors. Already errors are squared and you have added. Added you can't get the negative value. 100% you can't get the negative value. Only positive value is possible. In the least case, 0 is possible. So 1 minus 0, that is the maximum best you can get. 100% is the maximum accuracy which you can get. Is that clear? So now here the maximum value is 1. When it is going to be possible means when SSC of your regression line is equal to 0. In that case only it is possible. Otherwise it is not possible. Now what is the minimum value? Minimum value can be minus infinite to anything. Because sir, now R square can be negative also. Yes. For example, your regression line is performing. For example, average line you have got 22. Regression line you have got something like 160. Now in this case, what happens? Automatically your R square will be negative. In that case, regression only will be best. In that case, regression only we should not apply. If the R square is negative, regression is the worst model. Don't select the regression model. That is the meaning of that. Is that clear? So now let me explain with a simple example. X is equal to 1, 2, 3, 4, 5. Y is equal to 6, 7, 8, 9, 10. This is the data set. For this data set, I am going to calculate first model. I am going to calculate the model. Model is x plus 5 is the model. And using this model, I am going to make with respect to, for this model, without the model, first let me try with SSC of average. That is, y is 6, 7, 8, 9, 10. Average value is, what is the average value? 8. That is y minus y bar, that is minus 2, minus 1, 0, plus 1, plus 2. And y minus y bar whole square is 4, 1, 0, 1, 4. And sum of y minus y bar whole square is equal to 10. In this case, no regression equation is there, nothing is there. Nothing is there. Directly I have calculated the sum of the squares of errors, assuming this for everything. I am predicting the y hat as 8 only. For everything, I am predicting y as 8. The difference of these two is this one. For everything, I am predicting 8 only. There is nothing regression is there. Now, using the regression model, what I am going to do is y is same 6, 7, 8, 9, 10 only. Now, this time I am going to use the model. Model is x plus 5. Using that model, I am going to predict the y hat values. That is 6, 7, 8, 9, 10 is the predicted values. Now, once I predict, now what is the error? 0, 0, 0, 0, 0. And what is the squares of errors? Miss 0. And what is the total of y minus y hat whole square? What is the total? 0. Now, what is the R square? In this case, miss 1 minus 0 divided by 10, which is 1. 1 means 100%. This say y is equal to x plus 5 is a 100% equation, perfect equation. For example, assume that here there is a value of 11 is there. Now, it is not 100%, right? We can't predict the equation with 100%. With 92% or 93% or 95%, whatever it is. But 100% we can't get. If there is a proper pattern is there, 100% we can get. Is that clear, guys? In the last class, I have done the same thing. That is, first, let me clear the outputs. I'm importing the pandas. First, I'll import the pandas as PD. After that, X values and Y values. And I'm going to create the data frame. And for this, I have told you the linear regression and model.intercept and model.quotient. And how to predict the values. Miss, this is going to predict the values in this way. And the Y-pred values are, this is the Y-pred values. That is Y and Y-pred. Y is 6.45510. And Y-pred is 4.2, 5.1, 6, and 6.9 and 7.8. And for this, you have calculated the sum of the squares of errors of average line. What is the sum of the squares of errors of average line? 22. And sum of the squares of errors of regression line. What is the output? 13.8. Now 13.9. 13.9. Now you are going to calculate the R square. R square is equal to 1 minus 13.9 divided by 22. Now, the same thing we are going to calculate in the same way, that is called as model dot score. Our model score, I'm going to calculate the model dot score. Inside that, I'm going to give this X value and Y value. Whatever I have given here, the same thing I'm copying. And I'm giving this same X value and Y value. And I'm asking, it is with respect to the same answer. So here it is having 36% only. The relation between these two with 36% only you can predict. You can't predict the 100% accurately. Data is not supporting this. How we can get the values? For example, let me write like this. Data set 1, 2, 3, 4, 5. First one 100. This one is 2. This one is 4,000. This one is 20. This one is 20,000. I have written randomly. Right? Now for this data set, what is the expected value of 6 miss? How you can calculate? Is there any pattern is there? So in this case, if you apply linear regression, if you try for linear regression for this data set, you will get the R square as negative also. Linear regression also will not be fitted for this. If there is a pattern is there, that using that pattern for the future data, we can predict. If there is no pattern, how we can analyze the data and how we can predict? Right? Data scientist is not always getting 100% accurately. We can't predict the 100% accurately. We'll try to predict to the maximum. For the given data, we'll try to predict to the max. Whatever the extent we can try. So for example, for this data set, what is the expected value of 6? Model dot predict. Whatever the model dot predict is there. For 6, what is the expected answer, guys? Just keeping the equation. That is 3.3 plus 0.9 into x. X is nothing but 6. 3.3 plus 5.4, which is 8.7 is the expected answer. So model dot predict of this one If you give the value of 6, it is going to give the output as 8.7 as the answer. Sir, 8.7, you are saying the expected answer with how much percent of accuracy? What is the accuracy, miss? 36% is the accuracy. With 36% accuracy, I can predict the answer as 8.7. For this data set, that is the only thing. For example, the data set I am changing like this. See, 1, 6. Let me change the data set. 6, 7, 8, 9, and 10. Now, by using this one, if I create the data frame like this, and if I'm applying the linear regression, the quotient is going to be 5, 1, that is x plus 5. The equation is going to be x plus 5 for this one. Now, using this one, if I predict the answers 6, 7, 8, and what is the score, miss? I'm going to get 100%. Now, model.predict on 6, miss, answer is 11. With 100% accuracy, I can say it is 11. If the data set is like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, with 100% accuracy, I can predict this one with 11, 100% sure. R square is 100%. Is that clear? So we are not going to predict every time with 100%. 100% prediction can be done with the proper data is there. For example, for this data, assume this value is 11. So now for what is the expected value of 6, miss? You'll predict, but it is not 100%. You can predict the answer, but it will not be 100%. You can predict up to 90% or 80% or whatever it is, but not 100%. Right? So if I apply the linear regression over the given data set and the intercept value and the quotient value, and if you check the score, means 97%, you can predict the answer. For the 6, in the future data for 6, if this is the past data, for the future data, this is the expected value. Now, for example, morning, 6 p.m. batch is there. 6 p.m. batch, I'm having the students of 130 students are there. 7:30 p.m. I'm having with respect to 160 students. Now, tomorrow I'm going to start in this weekend. I'm going to complete the 6 p.m. batch. And I may start the 6 p.m. batch in the later, assume. In the future, I want to start the 6 p.m. assume. Right? Don't ask me the date. I only don't know. Okay, don't ask the date. Just example only. Now, in the future, just for the 6 p.m., what is the expected number of students? Miss, just you are going to take the average of these two, right? Basically, average only. If you are having only one data, it is average. If you are having 2 columns, then only you can apply the regression. The dependent variable and independent variable. For example, if I keep the classes at night 10 p.m., I can't take the average now. Average of these two cannot be applicable for 10 p.m., right? Average of these two cannot be applicable for 2 a.m., right? So here 130, 160 is there. So 145 students I can expect for 2 a.m. also I can expect 145. No, right? If I start the class at 3 a.m. means also I can expect 145. It is not possible. Right? So there is some relation between these two. First, identify the relation between the timings versus number of students. And based on that, if the time was changed, how many expected number of students? That will be checked. This is called as time series analysis. If the time is involved, means it is time series analysis. It is not called as regression. Don't apply the regression on that. Time series analysis is different, where we are having with respect to time and the data. Based on the time to time, the data, and we are identifying the relation between both of them. Right? So here regression means identifying the relation between two things. What are the two things? Means one is independent variable, one is dependent variable. Right? Now we are going to start the first project. Project number 1. So now in this first project, so we have to involve the entire life cycle of the project. That is first business understand what is the project, for what purpose you are doing this project, what is the requirement of the client or the person who has given the project. Understand the data very clearly, data set very clearly, do the data preparation or data cleaning or everything, and apply the modeling and evaluate the model. And this model, if it is satisfied by the business person, means whoever has given the client, for example, his target is 80% is the accuracy he is expecting. If my model is satisfying, miss, I'm going to submit. If it is not satisfying, miss, I will recheck with another model. Like that, I will try with all the models. Right? So here, just I'm going to show you the first project. So here the business problem is based on the sales data set. Okay, the first business problem which I'm going to start, first project which I'm going to start is on the sales. So here they want the relationship, identify the relation between total advertising spend versus sales. Total advertising means they are spending on the different things, and they want the relation between total advertising versus sales. And in the next ad campaign, if they spend $2 lakh, $200,000 if they spend, what is the expected number of units? This is the question. This is the business problem. For that, what we have to do is first we have to load the data and we have to understand the data. So here I'm having TV, radio, newspaper, and sales. So they have spent some amount on TV. They have spent some amount on radio. They have spent some amount on newspaper, and this is the expected sales they have got. Not expected, already sales. Some sales they have got. Second time they have done the advertisement like this by spending, and this time they have got the sales like this. Next time they have spent this much of amounts and they have got the sales like this. Next time they have spent this many amounts and they have got the sales. Like this, every time they have spent different amounts and they have got the sales. This is the past data. Now using the past data, we have to predict for the future data. First, we have to analyze the past data. Is there any relation between the advertising amount and versus the sales? If I increase the advertising amount, sales are increasing or decreasing? Is there any relation between them? First, I want to identify that one. If I identify the relation, and I'm going to substitute in the equation. So here, what is the question is relation between total advertising, not with respect to individual. Total means first you have to create a new column called as total. You are going to create a new column total. Total is nothing but combination of everything, this one. And whatever the remaining 3 columns are there, I'm removing. Now I'm having only 2 columns. One is total and one is sales. Now they want the relation between these two. Once you identify the relation, whatever the relation you have identified. Now, for example, you have identified relation is equal to something like X, that is 400 plus 5 into total spend. Something you have identified the relation like this. This is the intercept value and this is the quotient value. Y is equal to mx plus c, that is beta naught plus beta 1x. So beta naught value is 400, beta 1 is 5. You have identified the relation like this. Now for $2 lakh, what is the expected value? Miss, just you have to substitute here $2 lakh. And you are going to get the expected y hat. Right? So what I'm going to do, first I will do the data pre-processing. I have first step is first business problem. I have understand my business problem clearly. What is the business problem is first I have to identify the relation between total advertising spend versus sales. That is the first step. Second one, I have to predict for the $200,000 what is the expected number of sales. This is the second one. So my business problem was clear. Now, miss, they are asking the relation between advertising spend versus sales. First, I have to identify that one. Now, for that data, first I am going to collect the data. Whatever the data was collected by the data engineer team, they are going to share it to me and I am going to load that one. Okay, data collection is done. Now I am understanding my data set. In my data set, how many rows are there? Understanding each and every column name is called as data understanding. You have understand what is meant by TV? Means how much amount they are spending on the TV. Radio, how much amount they are spending on the radio. How much amount they are spending on the newspaper. And their sales. What is their sales of a particular product? Assume that product is some phone, mobile phone. They have given the TV advertisement, radio advertisement, newspaper advertisement, and these many number of units has been sold. Assume this is the number of units. For example, Samsung mobile is there. Samsung mobile will see in the TV, right? In the TV advertisements, we'll see with respect to Samsung mobile, whether it is a Z Fold or whatever it is. We'll see some advertisement. Same advertisement will get in the radios. That is, Samsung has released latest mobile with the fan edition, FE21 series, something. And newspaper. On the newspaper also, in the first page itself, we'll get with respect to some advertisement posting that mobile phone. So now how many number of units? They have done all these things and they have checked how many number of units has been sold. Second time, one more next month, they have given with respect to one more time. And again, they have checked. Again, they have checked. Now they want to identify, is there any relation like that? Right? Now, so here, I'm going to do the data set understanding. Data set understanding is where I'm having with respect to 200 entries. Means 200 records are there. Right? Now, using these 200 records, now what I'm going to do? First, EDA. EDA means just I'm going to apply the descriptive statistics. So what is the total spend they have done? Mean value of total spend is this much. And with respect to minimum value is this much. And this is the maximum value. Similarly, in the sales also, minimum sales of units is this much to the maximum number of sales is 27,000. First, I'll understand the statistics. After that, I will apply the relation. I will see the scatter plot. In the scatter plot, I will identify whether the direction is positive or negative. So, I'm applying the scatter plot. So, in the scatter plot, I want the sales on the y-axis. Sales on the y-axis, total spend on the x-axis. Means this is the scatter plot which I have to observe. So, in the scatter plot, I can see clearly this. It is in the positive direction. Means as x increases, y also increases. Means the slope is positive value. Whatever the slope you are going to get, y is equal to mx plus c, that is beta 1x plus beta naught. This beta 1 is going to be positive only. 100% is going to be positive. Because the direction is positive direction, so beta 1 should be positive only. Now, first I have observed in the scatter plot, what is the direction? Now I have observed that second one is how much close to the data points. How many the closeness of data points. They are very close to each other or somewhat very far away to each other. If they are very close to each other, means the correlation will be very high. If they are far away to each other, means the correlation will be low. I can't say exact value. I can't say exact value, but I can say that whether it is a good or bad, that only I can say. I can't say exact correlation value. From the scatter plot, we can't identify. Similarly, the third one, total 3 things you will identify from scatter plot. First one is called as direction. First, you are going to observe the direction. Second one, you are going to observe the strength. Strength is nothing but whether how much they are close to each other. That is the strength. Third one you are going to identify is linearity. Whether you can apply the linear regression over this one or with respect to non-linear regression. So if you can fit a straight line like this, you can fit a straight line means you apply the linear regression. If the scatter plot looks like this, in this case, we are going to have with a non-linear curve. So based on the scatter plot, we are going to identify. And we are assuming only. We can't say exactly. Sir, for example, I'm having the data set like this, sir, but slightly bend is there, but almost everything is close. We'll try with linear and we'll also try with non-linear. It is an assumption only. We are assuming it is a linear and we are applying the linear regression. It is my assumption. May or may not. Right? Now, since the data points are very close, automatically the correlation should be very high. So correlation also 0.86 is the correlation value. Means the relation between y and x is 86% correlation is there. The higher the correlation, the more accuracy we'll get in the data. Now what I'm going to do, I'm going to clean the data. Is there any cleaning? No. No missing values are there. Nothing missing values are there. So I no need to do the encoding also. Compulsory things are missing values and encoding. These are the 2 things compulsory. Sir, what about the outliers, sir? Outliers, now with just a model, you are doing a modeling without treating the outliers or without transforming the data to normal distribution, nothing, no modifications is done. Directly you are taking the data, whatever the data is there, directly you are giving to the model. It is called as baseline model. The data, whatever you are going to give to the model, it is called as baseline model. The data, here I am not going to treat the outliers. Whatever the outliers are there, including the outliers also, I am going to apply directly. I will not treat the outliers also. without treating the outliers, without doing the transformations, without doing scaling or nothing, without doing anything. Directly you are selecting the data and directly you are giving to the model is called as baseline model. Okay, in the interview they'll ask this question. What is meant by baseline model? Baseline model means for the given data directly applying the model and checking the answer is called as baseline model. Right? So for this data, whatever the you have to apply the baseline model means minimum thing you have to do is missing values and encoding. These two compulsory you have to do. Otherwise, model will not fit. It will throw an error. These two are compulsory. Missing values and encoding is compulsory. Outliers treatment or scaling or doing the transformations, converting skewed distribution to normal distributions, these are optional. They are not compulsory, optional. Right? So here what I'm going to do is, I'm going to apply the train test split. Before applying the train test split, first I want to take the X. What is X? Total spend is the X column. What is Y? Sales is the Y column. So how to select the X means df dot drop of columns is equal to sales. You can write like this, or in the second way, you can write even in this way also. That is X is equal to df of whatever the column, that is total spend column. Directly you can select the total spend directly like this. This is the second option. But remember, the X should be with respect to a two-dimensional. Otherwise, it is not going to accept. It should be a two-dimensional. So whatever the X you are going to consider inside the X, you have to keep with a list of X values. Though it is a single column also, list only you have to consider. List of column names. X always should be df of bracket and list of columns. Always it should be like this only. Whether it is a single column also, you have to keep inside the list only. Whether it is multiple columns also, you have to keep inside the list only. That is compulsory for any algorithm inside the machine learning. And sales, Y is equal to df of sales. So now the X value and Y values are ready. If you want, you can check your X and Y also. First type the X. X means total spend. And Y is with respect to sales column. X and Y are ready. Now what we are going to do is, we are going to split the data with respect to X train and Y train, and X test and Y test. So here the most important concept comes into picture, that is called as dividing the data. Whatever the data is there, we have to divide the data into two parts. One is called as training data and one is called as testing data. Sir, why we have to divide? If you don't divide, what happens? Directly, if you can give entire data na, for training purpose, it will only learn, right? Now, let us start this one. What is meant by train test split? We are having with respect to training and testing on the same data, train test split. These are the two options which we are having. So first one and second one. So first one is, for example, if you are training with 1 plus 2 is equal to 3. 3 plus 3 is equal to 6. 1 plus 9 is equal to 10. You have trained a particular student, you have trained like this. These three examples you have trained. In the exam also, you have to give 3 plus 3 only. You can't give 4 plus 3 also. If you give 4 plus 3, they will not write the answer. Then it is called as train and test on the same data. Same data means whatever you have used it for training purpose, in the testing also we have to get the same. Means whatever I am explaining in the class, if I am doing any kind of mock interview, you are expecting the same questions in my whatever I have discussed in the class, right? For example, in your college days, in your college, if any professor explains a subject, in the class he will explain a subject, some subject and something. And he will keep in the question, he will keep one exam, that is external exam. In the external exam, the question should be within the whatever he had discussed in the class only. For example, he has asked out of that one, which is application of that one. If we ask any question, what we'll say? It is called as out of syllabus question. Right? We expect only the questions, whatever he has discussed in the class only. As it is we want. He has to tell us the question, answer, question, answer, question, answer, question, answer. If possible, important questions also. Still, if it is possible, tomorrow's examination question paper also, right? But in real life, we can't do like that, right? So if you are preparing in that way, for example, sir, what are the questions I'm getting trained? I want the same questions. Miss, you can't take any kind of competitive exams. For example, in IIT exam is there. IIT questions, the trainers will discuss in the class. That exam questions. Similar pattern of questions they will discuss in the class. They will train the different types of data and different examples. But not the same example will be in the examination hall, right? Astis example will be in the examination hall in IIT or MCET exams, right? Here we have to understand the concept, not with respect to the examples, and we should not ask the same questions. Now, what happens if you ask the same questions, miss? For example, there is a data set like this. Now, entire data you have used it for training purpose. Complete data you have used it for your training purpose, and you have prepared the model, linear model or whatever it is, model was prepared. In that, some of the data you have used it for testing purpose. Within this only, whatever you have used it for training, for example, in the class, I have given the questions. And in the interview also, you have to ask the same questions only. Then the student is answering some answers. And we are evaluating that one. Now, here, for example, let us assume in the class, let us take simple way. In class, I have explained you 100 questions. 100 questions with answers I have explained. In the class, I have explained you. Every day, I am explaining something. In the interview, out of these 100 questions only, I am asking 5 questions randomly. And you are giving the answers. What are the answers you are giving? And I am comparing with the original answers. Whatever the original answers are there and whatever the answer you are telling, I am just comparing, which I am going to call as testing marks. I am going to give the marks. These 5 questions were asked out of these 100 questions only. Out of these 100 questions only, I am asking 5 questions randomly, and for that, you are giving the answers. This is called as in-sample test data. Means where whichever you use it for training purpose, the same questions are used for testing purpose. Now, this person, if I ask the questions, now this person says that out of these 5 questions, 4 questions he has answered correctly. Now, 80% marks he has got. 4 out of 5 means 80%. 80% marks he has got. Now, what is the meaning of 80% marks? Means he will work only on the given data only. So in this case, what happens? The entire data you are using for training, within that only you are using for testing, means high train accuracy will be there. Train accuracy will be very high. Training means whatever you have used it for training and you are asking the same questions, na? Train accuracy. Train accuracy will be very high. Now the same person comes out of the institute and if some other person is asking the interview questions, means he will fail there. Low out of sample accuracy. Out of sample means out of that, if they ask means they can't give the answers. Is that clear? For training purpose. Now what we have to do means part of the data we have to use for training purpose and part of the data we have to use for testing purpose. Which you are using for testing, that should not be given in the training. The same thing which we have done in the assignment 1. In the assignment 1 or assignment 2 or whatever the assignments I have shared you till now, never I have discussed the answers in the class. Training is different, testing is entirely different. If I want to test, if I want to change that one, directly I can bring that one also in the training only, right? That same questions I can bring in the training, right? So here the entire data has to be split into 2 parts. One is for training purpose and one is for testing purpose. Now, whatever the data was selected for training, it should not be given for testing. Whatever is used for testing, it should not be given in the training. Both are exclusive. There should not be any kind of intersection. There should not be any common things. There should not be any kind of intersection. Both of them should be exclusive to each other. Now, in this case, what happens? Whatever the based on the training, now you are predicting on the new data. You are giving a completely new data and you are predicting the answers. Now you are matching to the original answers. Now your model, how much it is performing well, means this is the actual way of predicting the answers or testing the machine. Now in this case, what happens, miss? You'll get a better accuracy in the future data also. In the last case, for example, if you go with this one, here it is called as high training accuracy will be there. low out of sample accuracy will be there. Means low test accuracy will be there. In the colleges, for example, the person will be there. In the college, he will be having BTech 80%. But in interview, job will not be there. 80% BTech knowledge is there, but no job is there. Is there any logical? 70% of BTech percentage, 70%, but no job. What is the meaning of that? What is the meaning of that? 70% of the syllabus means how much percentage of BTech syllabus is 45 subjects, including your labs, including everything. Inside that 45 subjects, 70% of the syllabus, 70% you know means how many syllabus, how many subjects you know? With that many subjects, you can't get even one job. 80% you are saying that my BTech percentage is 80% means, you know, your percentage is that much of means how much subject knowledge you are having. With that, you can't get one job, small job also. What is the problem is? That is the problem. In the class, whatever they have explained, that only they know. Out of the sample, nothing. Right? That is the reason why many of the students are failing in the interviews. Right? So here the high training accuracy will be there. High train accuracy means training accuracy will be very, very high with respect to the BTech percentage. In the interview, the score will be very low. Now, here in this case, what happens if the both of them are exclusively? This is more accurate evaluation for the out of sample. Now, what of the out of sample questions are there? This is purely his knowledge only. Now, in this case, he has got 60% means really 60% knowledge only. 70% means 70% knowledge, because this is entirely new now. Completely new questions, completely new. He don't know anything. Right? Now, whatever your GATE exam percentile is there, percentage or whatever it is, that is your actual BTech percentage. That is actual BTech percentage. Industry will believe in that. That is the reason why they give the priority for the GATE exam. And almost 90% of the people will not be interested to take the GATE exam also, because they can't remember 4 years subject. There is multiple reasons are there. Finally, I don't want to say that every student is like this, but now from this you have to understand in what way you have to prepare. Don't expect the same questions what I am discussing in the class as it is same question. Everything will be with respect to application oriented. That is the reason I'm asking every time, are you understanding the concept or not? Not the example. Right? If you understand the example means, that is called as by-hearting. Again, you comes under this category. Clear, guys? So the data should be split into two parts. One part is for training purpose and one part is for testing purpose. That too randomly. Which we are going to choose, we also don't know. Randomly we have to choose. Randomly we have to do that one. So here the train test split, I am going to do that randomly. So what happens now, you know, train test split means you are going to split the entire data of X. X is whatever the data of X column is there, that is total spend. Inside this total spend, total how many records are there? 200 records are there. Now out of these 200 records, test size of 0.3 means 30% you are using for testing purpose. 30% of 200 means, which is 60 records. So you are going to use the 60 records for your testing purpose. Randomly you are going to choose 60 records. You are separating them. Now for training purpose, you are going to use only 140 records. 200 into 0.7, which is 140. 140 records are used for training purpose and 60 records are used for testing purpose. These 60 records are there. The machine also don't knows. Whether the 60 is there or not there, the machine don't knows. It knows only this 140 records only it knows. So now what I'm going to do is, here the X data I'm going to divide into two parts, and Y data also I'm going to divide into two parts. X data I'm going to divide into two parts. First part X, write in your notes clearly. X part is divided into two parts, which is called as X train and X test. Y part is divided into two parts. One is called as Y train and Y test. First part is training and second part is testing. So that is the reason here I am assigning to four variables: X train, X test, Y train, Y test. X train, X test, Y train, Y test, where this X was divided into two parts. First part I am going to store in the training. Second part I am going to store in the testing. Similarly, Y first part I am going to store in the Y train. Second part I am going to store in the Y test. Okay. For example, let us take like this: X and Y. Assume 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 records, total 5 records. Total records. Don't write. After once it is clear, then you can write. Test size. I am going to take the test size is equal to 0.2. Automatically, test size is 0.2 means train size is 0.8 only, 80%. Obviously. Now, you select anything as per your choice. Okay. 0.2 into 5 records, which is 1 record you have to use for testing purpose, and 5 means 4 records you have to use for the training purpose. You have to select any 4. Choice is yours. Select any 4. For example, I am selecting this one, this one, this one, this one. This is used for testing. These 4 are used for training. Now, this, whatever the 4 records are there, 1, 3, 4, 5. This is called as X train. Now, what is X test? Balance 2. This is X test. Similarly, Y train. The corresponding X values, what is the Y values? 6, 8, 9, 10. These 4 values are Y train. And this value, whatever the 7 is there, this is Y test. This is the training data. This is the testing data. Now I am going to fit on the machine learning only on this one. By using these 4 records only, I will calculate the linear regression. I will not give this value and I will not apply the linear regression on this one. I will apply only linear regression on this. And once I do this linear regression on this, later I will evaluate. I will evaluate and I will check with respect to what is the expected output if it is 2. And based on that, I am going to calculate the accuracy. Is that clear?